going to use this microphone. So with that introduction, we already know that all the non-technical people in the other session, and now all the technical people go, what do I do? First of all, it's great to be here. It's a great honor to speak at this conference and to be able to share this presentation with you. As already said, I'm going to be speaking about technical things, and I'm going to try to put in a text that people that aren't so technical can get it. And to start off with, I want to start off with a story. Now, when I turned 13, my parents bought me an awesome gift. They bought me a skateboard. Now, this wasn't your ordinary plane-shaped skateboard. This is what we call, it had a cruiser deck. It's one of the coolest things a 13-year-old will ever see. And having seen that board, I was inspired to realize my calling in life. I was going to become a famous skateboarder. So to start off with, I tried my hand at skateboard tricks. Airs, backslides, ollies, kickflips, you name it. And what I discovered with skateboard tricks is they all had one thing in common. They require coordination. So, having failed with skateboard tricks, I came up with a plan B. I decided what I lacked in coordination, I would make up with speed. And with this brilliant idea, me and my two younger brothers went off to find a hill to demonstrate my ability. Now, having grown up in KwaZulu-Natal in a place called Forest Hills, there was no shortage of options. In fact, just down the road from where we lived was a perfect specimen of a hill, and it had this newly tarred road going down it. And I remember this event as if it was yesterday. My brothers and I walked to the top of the hill, where I stood for a moment, looking down it as if I was a surfer, looking at a large wave. And then, with nerves of steel, I climbed on my board and began my descent. About 10 seconds into the ride and 5 meters down the hill, I suddenly had a feeling that this wasn't such a great idea. While my board was doing really well and rapidly increasing in speed, it occurred to me that there were a few things I hadn't considered. First of all, the hill I was riding down came to an abrupt stop at the bottom where it joined the T-junction, and cars traveling along the bottom had zero visibility of anything coming down it. And then secondly, and more importantly, I wasn't dressed for the occasion. I was wearing shorts and a t-shirt, and that's it. Absolutely no protective gear. So, as these thoughts occurred to me, I made the first good decision of that day. I jumped off. Now, as I jumped off, my world went into slow motion. The board that was just seconds before under my feet continued down the hill and then it veered off into the bushes and came to a stop. I also continued down the hill for a couple of meters, and with no protective gear, I had to rely on my hands and knees to help me come to a stop. I remember standing up, looking down and being surprised that where just seconds ago there was healthy skin, was now replaced with blood and torn flesh. Now, in my experience as a software developer, I've seen many organizations make the same mistake that I made on that day on my skateboard. You see, these organizations want to develop software faster. They've sent everybody on an Agile course. They've bought a Scrum board. They're doing daily stand-ups. And they've missed something really important, and that is this. If you want to develop software faster, it's naive to think that the only thing you need to change is your interactions. You also need to adjust your engineering practices to work at the same rate of change as your interactions work. How do so many organizations miss this? Well, in my mind, two of the main reasons is the two most popular methodologies, Scrum and Kanban, don't specify any specific engineering practices. Now, this doesn't mean that they advocate bad engineering practices. They're just not specific on what the good engineering practices are to be able to release at the rate that they want you to do. And this is a problem. This has left many organizations not aware that there are additional skills and abilities that they need to develop, additional engineering practices they need to adopt to be able to develop software at an agile release rate. And that's really what inspired this session today. Today I'd like to talk about the natural order of progression of agile technical practices. Now, What are Agile Technical Practices? Well, when I ask this question to people involved in software development, I get a range of answers. And today, for this session, I'll ask you to use my definition, which is Agile Technical Practices are specifically the engineering practices used in an agile environment. These are engineering practices appropriate to release at an agile rate. Now, with that, I want to talk briefly about team and organizational structure. Kent Beck did a wonderful talk at Lean Canada in Central Europe a couple of years back called G-Force. And in his talk, he spoke about how different rates of delivery require different structures and activities. I'm going to work on the assumption that you already have the correct team structure set up. I'm going to assume that you have small, cross-functional teams that are under pressure to deliver working software regularly. With that said, what I found is engineering practices and team structures are joined at the hip. That means that certain engineering practices are almost impossible to do effectively unless you have an appropriate team structure to support it. So if you're unsure whether you have the right team structure for how you're doing things, I really recommend watching Kent's talk and getting an understanding of what's appropriate to the different rates of delivery that you want to deliver software. Now, before I speak about specific engineering practices, I want to talk about one other thing that's just as important to allow good engineering practices to happen. And that's the necessity of teams having Slack. One of the most valuable things you can do for a team is help them create Slack. Now, when I talk about Slack, I'm referring to the time the team has to learn and adopt new engineering practices and to upskill. If a team doesn't have Slack, they won't be able to improve, which means things won't get better. And a good rule of thumb with regards to Slack is to prefer small, frequent intervals of Slack over large, infrequent blocks. So it's my experience that teams that have small daily and weekly sessions built into their normal routines learn and improve at a much faster rate than teams that take a large time off to learn something new. In the team I'm currently in, we've experimented with various forms of learning things, from weekly lunch sessions where we talk about design principles, to doing katas where we learn new techniques, to taking time to watch recordings of conference videos and topics we find interesting. The important thing is this: it doesn't matter how your team does it, encourage them to learn new things regularly. Now, when a team or an individual learns a new engineering practice, you need to be aware that a dip will occur. Sometimes this is called the J-curve effect. And this is important that you need to know that it exists. There will always be an initial dip in performance while our team is learning a new practice, and as somebody that's not necessarily involved in that practice, you need to have enough of an understanding of the benefits of that practice in the long run to be able to support teams and individuals through that initial dip. Now, this might sound all great in theory, but in the real world, we can't tell people to stop working. We have deadlines. Well, I've heard this statement a few times. In my mind, this comes from a resource utilization mindset. First of all, there's very little correlation between how much work gets done and how busy somebody is. And secondly, there are approaches that you can take that don't require you stopping the ship, that still allow you to create Slack. For instance, you can invest in practices that have a shallow dip and a quick recovery period. Now, these practices might not be the most beneficial long-term practices to adopt, and they might be extremely useful to create the initial Slack to tackle the harder and sometimes more time-consuming practices. The approach I like to take is as follows. As a team, identify your existing bottlenecks. Then as a team, identify the practices that you can apply and get a rough idea of how expensive those practices are going to be. Pick an appropriate practice, learn, understand it, apply it to your system, and with time, you'll start to realize a return on that practice. That additional capacity that you create, instead of putting it towards development, allow the team to reinvest this towards the next bottleneck. What you'll find is eventually you'll create more capacity than the time that you need for Slack. And when you do this, you'll become progressively faster. And the interesting thing about teams that become progressively faster is it becomes addictive. The faster you go, the faster you want to go. So with that said, I'm going to speak about the first technical practice. And the first technical practice I want to address is effective version control. Now, All the teams I've spent time with recently have a version control system, and many of them are using it wrong. You see, many of them view version control as merely a backup tool. Version control is not just a backup tool. It's also a really powerful integration tool. One of the major benefits of a version control system is it takes away the pain of resolving merge conflicts. This means that multiple people, multiple developers can work in the same code base at the same time, and the version control system will do the majority of the work in taking their changes and putting it back together as a single system. Now, one of the common symptoms of misuse is when a team regularly complains of merge conflicts or having to always manually merge the work. This symptom is caused by teams not continuously integrating. Continuous integration starts as a discipline. Teams need to continuously integrate to trunk. Now, it's my observation that if your team has a murmurings that their version control system is not working, or how they hate their version control system, you're going to be dead in the water trying to get any of the more advanced technical practices implemented. It's just that important. And the pattern of version control is really simple. Do small bits of work and integrate frequently. Now, following effective use of version control, I want to speak about automating and democratizing the build. Now, this seems like such a simple thing, but I've come across so many teams that haven't done it. When I refer to the build, I'm referring to the set of files that are generated or packaged that allows somebody to run a system in a test or production environment. Now, in organizations that previously released infrequently, this is often a manual process owned by a single individual. When you automate and democratize the build, you move it from being a manual process to being something run automatically by a script file. And you put it in such a way that anybody in the team can execute it. Now, many teams that I've come across will tell you that they're the special case, that they have the tricky technology stack, that their process is so complicated that they have to have this one particular individual do it. It's my experience that I've yet to come across a team that hasn't been able to automate and democratize the build after having applied their mind to it. Now, I just want to share a quick experience in this. And we've experienced this many times. I once worked with a team that was working on a particular legacy system that under a huge amount of pressure. And one developer in that team stood out as being exceptionally busy. After spending some time with that team, we noticed that every couple of weeks he would disappear for a day to go and make a build for the testers. Now, because of the pressure he was under, occasionally he would miss a step in the build process, and you'd end up with a build with an old file in it. This would only get picked up by the testers after several hours of testing. So you can imagine how popular this developer was with the testers after they just discovered that several hours that they put in now had to be thrown away. You can imagine how much that developer loved his build days. Well, after some encouragement, we managed to spend some time with them to help them automate and democratize the build. We eventually got it to the process where you could run a file and your build was created. What once took several hours was now reduced to a matter of seconds. The interesting thing is when you automate and democratize the build, you make things become less painful. Things that are less painful are done more often. When you do your build more often, you do more frequent builds, which leads to smaller, more frequent releases, which also leads to business realizing their features sooner. This is the value from getting automating and democratizing the build. It's something I really recommend you do. So doing smaller bits of work and integrating frequently means that people work closer together. When people work closer together, it's important to make build and integration issues clearly visible to the team as quickly as possible. This is done by setting up an integration server. Now, a continuous integration server, sometimes you'll hear it referred to as a build server. What it does is it builds your code base whenever a check is done to your version control. And its main responsibility is this. It makes sure that all the files are there, and it makes sure that they're playing nicely together. One of the major benefits of a continuous integration server is it shows the health of your build and makes it visible to the entire team. Many of the teams that we've worked in, we've plugged a monitor into our continuous integration server. Whenever a developer did some work, the CI server would pick it up, it would start a build. It used 3 colors. Orange meant it was currently building, Green meant build a success, carry on, and red meant that we had broken something. We knew that when the continuous integration server went red, we needed to stop what we were doing and fix the bug. One of the major advantages of making the continuous integration server visible to the whole team is it helped us focus on resolving integration issues quickly. Another thing it helped us focus on is teamwork. It helped support that in the back of the mind that we weren't just individuals, that we were working in the same team, on the same system, and that our actions had an impact on somebody else. Now, if you've already got effective version control system happening and you have your build scripts humming, setting up a continuous integration server is often trivial. It's something every team should have. So, with that said, let's assume that you have a continuous integration server set up and that you're realizing value from it. What are some of the practices to consider from there? Well, it's at this point in time that I'd like to talk about the principle of collective code ownership and some of the practices that support that. Collective code ownership is the principle that code belongs to the system, not to the person. And what this means is when somebody is making changes in the system, they can make changes to any part of that system without fear that they're stepping on somebody else's turf. One of the practices that support the principle of collective code ownership is the practice of the team having a common coding style. Now, by this I'm not referring to a thick document put together by the architects in the architect forum. That does not work. Rather, I'm referring to a team having a common understanding of the style of code they write when they solve a problem as a group. Now, a practice that helps teams have a common style is the practice of collaborative coding. And on the diagram here, I've put various forms of collaborative coding. What I've found is the further right you go, the more the common style the team has. Now, for those of you that are unfamiliar with the last two terms, pair programming and mob programming, I'll briefly explain those. Pair programming is when two people sit in front of one terminal solving a problem. And mob programming is very similar to that, except instead of two people, you have many people sitting in front of one terminal solving a problem. Now, whenever I talk about pair and mob programming, and there are business people in the room, they say, that doesn't make sense. Surely if you have two programmers, you should have two computers and they should be working on their individual problems, otherwise they're not being efficient. Well, the best way I can explain why these approaches work is by explaining what we mean when we say we're programming. Programming is not about typing, it's about problem solving. And it stands to reason that depending on the problem that you're solving, it makes perfect sense to have more than one person work on that problem at the same time. A personal experience from my side is I have learned so many things in terms of design, in terms of structure, in terms of how to approach a problem when I've paired with other people and when I've worked on a problem as a group. It's that valuable. Now, following collaborative coding, there are a number of practices that we can adopt. I'd be doing you an injustice if I didn't speak about what I consider one of the most valuable practices, which is the practice of test-driven development. Now, having seen test-driven development grow in popularity over recent years, I've noticed a trend. People that haven't practiced test-driven development before, but have heard about it, often get confused between the concept of automated tests and the specific practice of test-driven development. I'm going to explain automated tests. Automated tests is merely that. It's a set of tests that you run against your system that tell you whether the system's working correctly or not. You can write these tests pre-development, during development, or post-development. My experience is the tests written post-development have no impact on the design of the system. Test-driven development is slightly different. It's a developer workflow. It involves a developer writing an automated test outlining the feature that they want to add to the system. They then write the least amount of code possible to get that feature to work. And then once the test is passing, they'll refactor the code to make it reach acceptable standards. Test-driven development has several benefits. The two that stand out to me the most is it helps create a simple design and it inspires confidence in developers that their code is doing what they expect it to be doing. And when I talk about simple design, the thing that stands out the most with regards to design is this principle of loose coupling. And when trying to think of like a non-technical analogy of why loose coupling is valuable in the system, the only thing I could think of was pre-TDD, if I was programming and programming was like building shapes out of building blocks, I was using large wooden blocks and glue to glue my shapes together. After learning test-driven development, it taught me to make my blocks a lot smaller and to adjust them slightly so they were more shaped like Lego blocks. Now instead of having to use glue, I could just clip things in and out into any shape I wanted. This is one of the major benefits of test-driven development. And in an agile world where we're embracing change, you can imagine what a competitive advantage this is. Now, if your engineers have not practiced test-driven development before, I'm going to warn you. It has quite a steep dip and quite a long recovery period. The first time I saw TDD being practiced, I saw a guy sit in front of his computer, he's typing, clicks a button, some lights on the screen go green, it's perfect, everything's working, and I went, great, I figured it out. All I need to do is go home, write some tests, and my world will be perfect. Well, I went home, I sat for 2 days, I opened up the system I was working against, I sat there, I failed dismally. I could not write a single useful test, let alone write it before the implementation. And it turned out the code I was writing up to that point was not testable. It was not put in such a way that I could test it. With that said, if TDD is so hard to learn, what's the best way to learn it? Well, in my case, it took a year of kind of dabbling with it, and a year of actually trying to apply it into my professional code before I actually got up and running. And the pattern for me is TDD requires time and exposure. If I look at a practical sense on like what learning resources I could use to learn TDD, probably the most beneficial thing I learned was going to code retreats. Now, code retreats are a day-long event of intentional practice in a collaborative environment. I fit a whole bunch of buzzwords in that one sentence. And in Johannesburg, we run community-driven code retreats a couple times a year. They're free and they happen on a Saturday. And that can sometimes be a challenge because often the people that you want to learn TDD aren't available to go to a code retreat on Saturday. So if you're in that situation, I really recommend looking at getting somebody to come and run an internal company code retreat. It's going to cost you a bit of money, and it's better than people not knowing how to do these things. Now I warn you, don't expect to end up with TDD ninjas after your first code retreat. It's going to require a long period of time and several positive exposures before people can actually start applying this in practice. That said, if I look at the benefits of what I got from TDD, it's a no-brainer. It's got to be absolutely for every company like something in their strategy for improving where they want to go, because it's taught me so many things from design, from getting feedback, from doing little steps, just so many things. So with that, we've touched on a number of technical practices today. Now this might not be the natural order of technical practices for your team. And that's fine. What I know is that different teams have different contexts. And so for your team, it might be a whole bunch of different technical practices that make sense. You can find your own pattern. All that you need to do is create slack in your system, identify your bottlenecks, and the practices that can help address those bottlenecks, and get an understanding of how expensive those practices are. Be strategic about the practices that you decide to adopt. Don't necessarily go for the most complicated practice first. Be strategic about it. Apply that practice into your own environment. And if you do that with time, you'll be able to discover your own natural order of progression. Now with that, I want to end off with a story of hope. A couple of years ago, before I was introduced to these agile practices, whatever you want to call them, I was involved in a system called MaxCut. And what we noticed in MaxCut is what we'd noticed in many systems I'd written before that, which was with time, it was getting slower and slower to add features, and we were losing more and more confidence in the system. One day I got an email from a user making a suggestion on a feature that looked incredibly useful, and just if I knew how hard it was going to be to put in that code, Like there was no way we were going to touch it. It was going to take weeks, if not a couple of months to do it. So I kind of shelved that request in the nice ideas but not going to happen section. About a year later, I was exposed to some of these technical practices. Most notably, the two that stood out to me was continuous integration and test-driven development. And one day I came across that feature request again. And I looked and I wondered to myself, if we were doing the right stuff, then this should be a lot easier to do now than it was a couple of years ago. Just so happened it was a Saturday morning, I had some free time, so I decided to sit down and try and code this. And I was surprised at how confident I was in working in that code. First of all, I was getting feedback from my tests continuously. And then secondly, the design principles I'd learned from test-driven development, I was seeing a real benefit in that loose coupling. I was able to pull things out and put things in. The net result being that by the end of the day, I'd not only written that feature end-to-end, I'd run a full set of automated tests against it. I had high confidence that it was working, and I had an automatic installation generated that I could deploy. And for me, that is what Agile Technical Practices are about. They give us the confidence to go faster, not slow all the time. Thank you.
Thank you so much, Mark. If you were aiming for making some of these technical terms and topics relatable to some of us non-technical people, I really think you achieved what you set out to do. So thank you so much. I certainly have learned something, and I'm sure there are many people in the audience that also can relate. And plus, guys, if you, I'm starting to index the world according to the spine model. And we earlier had Rowan talking more about a principle level, and I think you've shared with us some practices and tools which really supports and leads us from what we are talking on this morning. So guys, Mark available in the Indaba room. Yesterday, our experience report spoke about how some of these practices are affecting team people, and perhaps some of those questions will become relevant in terms of your experience and how people have reacted to it. So have that conversation with Mark. 10 minutes, we're back